So, since he already bored you too much, so let us solve an interesting and easy problem. Both interesting and easy. And the problem is two identical metal spheres are placed at large distance compared to their radii, of course, from each other and have charges q1 and q2. They are charged and they are having charges q1 and q2. An uncharged metal ball that must be identical, like previously two spheres. An uncharged metal ball of a thin, long conducting stick is brought to the first sphere and touched. Okay, their potential will get equal. Then the ball is brought to the second sphere and touched. Right? Get. After this, the charge of the ball turn out to be Q2. The charge on the ball that is being touched is equal to Q. Find the charge Q2K of the second sphere, final charge on the second sphere. So their potentials are going to be same in every touch. So let the charge of the ball, metal ball, before touching the second sphere, that means after touching the first sphere, becomes Q1. Q1 is the charge on the touching ball after first touch and before the second touch is Q1. So the potential of the ball, already charged ball, will have become Q1 minus Q1 by R. Or if R is this radius, so charge left on it is Q1 minus Q1, and that must be equal to 1 by 4 pi epsilon naught Q1 by R. And what will be its result? I am not going to take care of it. This there is simple result that can be written. And if it points you somewhere, go there. And now it's going to touch the second sphere. And after touching, the second sphere has got the charge Q2K. So I can write here 1 by 4 pi epsilon naught Q2K by R. That must be equal to 1 by 4 pi epsilon naught Q2 by R. Because Q2 is the final charge the touching ball gets after touching the second sphere. And you must be thinking like this. And you would be willing to write something like I'm willing Q1 minus Q1 by Q1, that will be equal to 1, and Q2K by Q2 must be equal to also 1 and so I'm going to get the result, that is Q minus Q1 by Q1, that is equal to Q2K by Q2, you can say. And I'm going to use the law of conservation of charge as well, because it is the most fundamental principle applied everywhere. So the charge before touching the second ball, it had charge Q2, and the metal ball that is going to touch it had the charge Q1, and the final charge on the second ball becomes Q2K, and the touching ball it becomes Q2. Okay, so I can write this conservation of energy. And if you wish, you can put the value of Q2K here, Q2K from here to here. if you wish, and you will get a result something like quadratic you will get, and its result is going to be q1 square plus q2 q1 minus q1 q2 equal to 0. Yeah, and you can get here all knowns q1 q2, only q1 is not known, so try to find q1, and q1 will be something here, what, minus q2 plus minus, I will avoid taking minus sign here, so plus under root q2 square plus minus becomes 4 q1 q1 and q2, yeah, by 2a, that is 2, yeah. So this is the value of q1, and after you got the value of q1, you can find the value of q2k from here, yeah. And you can see here q2k is equal to q2 plus q1 minus q2, and q1 you need to put here, and you will get the value of q2k, and that's your answer. Thank you very much for watching.